All right, in section 6, we kind of branch away from the solving equations part for a bit. We want to look at these three important words: ratio, rate, and unit rate. You've learned them before. Well, at least you've learned ratio and rate for sure before. What is a ratio? It does kind of look like a fraction. But what about it? Yeah, they compare two numbers usually, right? So a ratio is just a comparison of two numbers using division. For example, I could say 2 apples to 3 oranges. That is a ratio. And I can write it like this: 2 apples with a colon, 3 oranges. Right, so this is one way to write a ratio. 2 apples to 3 oranges is how you would read that. But we can also write it like this: 2 apples over 3 oranges. You still read it as 2 apples to 3 oranges because it is a ratio, but now it's set up more like a fraction, more like a division problem. And that's the way we work with ratios in algebra. So what is a rate? A little bit tougher. Actually, that is a rate. Yeah. That is a rate of change. How much am I going, how far am I going compared to how long it takes me, okay? So a rate is still a ratio that compares two different numbers. For example, I could say 60 minutes in 5 miles worth of walking or something like that. That's different than we normally would see the units miles and minutes, but that is a rate. All right, the last one, maybe nobody has seen that one before. What is a unit rate? That's actually pretty close, but it doesn't matter how much you get of the other. It's one thing, okay, in the denominator. So a unit rate has the word rate in it, so it must still be a rate, right? A unit rate is a rate with a denominator of what? 1. Anytime you see the word unit, a unit rate, a unit in different classes, unit vector, unit circle, things like that. That means, the word unit means 1, okay? So we have a denominator of 1 here, a rate with a denominator of 1. An example would be miles per hour. That's how many miles do you go in how many hours? 1 hour. Another one would be miles per, deals with cars also, gallon. That's how many miles can I drive my car for every 1 gallon of gas that I have to put into it. Okay? Yeah, hopefully it's more than 2 miles per gallon. That'd be a bummer. That's starting to sound more like my truck. You get like 12 miles per gallon. It's terrible. Okay, so you would normally see miles per hour as mph, and you would normally see miles per gallon as mpg. You watch enough TV, you'll hear about mpg all the time, especially when you're seeing commercials for hybrids and stuff. So if I have 65 miles per hour, if I'm going 65 miles per hour, then what that means is I have 65 miles traveled per 1 hour of time that goes by. That's a unit rate. So in this section, what we're going to be doing is turning ratios and rates into unit rates. Once they're unit rates, you can compare them. And actually, probably some of you have been doing this in your lives already. A lot of times when you go to, like if you go to a grocery store, you look at the price tags over at Ron's or something like that, and it'll say this steak or something is $9.84, and then next to that it'll say how much you're getting charged per ounce. That's a unit rate. So you use unit rates to compare prices to try to find yourself a better deal. Like if you buy the big container of orange juice compared to 2 little containers of orange juice, which one's the better deal? Maybe the bigger. Maybe not though. Sometimes orange juice, the cheaper one to buy is the smaller container, and you buy like 3 of them. When you want to compare a bunch of rates, converting them to unit rates is a good idea. It's pretty easy to do actually, and it's a skill that you're going to use your whole life because your goal in life is to spend as much money as possible whenever you go shopping, right? Sometimes it seems like that, but no, you don't want to spend all your money on stuff if you can save money on it, right? Because then you can spend more money somewhere else. So you're up in Billings looking at t-shirts, let's say. You go to Target and they offer $25 for 2 shirts. These are all the same t-shirts, by the way. Maybe white t-shirts, because you dress up. Sears offers the same t-shirts, $45 for 4 shirts, and Kmart offers $30 for 3 shirts. Which store has the best deal? How do you know? So let's write this down. We're going to make unit rates here. So for Target, they're offering what? $25, and for $25 I get the 2 shirts. Then we have, what's next? Sears. Sears says $45, and I get 4 shirts. So that's nice, I get more shirts, but I'm spending more money. And then finally Kmart says $30 for 3 shirts. So what we want to do is basically think of these as fractions. 25 halves, 45 fourths, 30 thirds. You want to reduce these down to just a number. That number then will be over 1, and that'll be your unit rate. So in other words, all I got to do is divide these 2 numbers. $25 divided by 2 is how much money? It's not 15. So 12.5. So in other words, $12.50 per 1 shirt. Is that a unit rate now? Yeah. For Sears, $45 divided by 4 shirts. Do we know that for sure? How would we figure this out? Okay, use a calculator. 45 divided by 4. What do you get? Only one person has a calculator sitting in front of them right now. 11 point what? Not 5. What'd you get? You're dividing by 4. 45 divided by 4. $11.25. So for Sears, we're going to get $11.25 per 1 shirt. So right away, who's the better deal between those two? Who's the better deal between those two?
Sears.
Sears is the better deal than Target is. Okay, Kmart, 30 divided by 3. $10 per 1 shirt. So to answer this question, which store has the best deal? The answer is Kmart does. $10 per shirt instead of $12.50 per shirt, or instead of $11.25 per shirt. So that's what a unit rate does for you. It allows you to compare, in this case, shirts from different stores so you can see how much you're actually paying per shirt. All right, what if Sears changed their price to $42 for 4 shirts? Does this change your answer? Why not? Well, they're on sale, right? Like Sears is making a big deal out of these shirts. They're on sale. Wouldn't change the order? Kmart's still cheaper? How do you know? We haven't even done any math here. How do you know? There you go. Good. Yeah, this would have to be $40 for 4 shirts to beat this or to meet this unit rate. So if these were like $39.99 or less, then yeah, Sears would have the best deal. So I don't even have to do any math here. Because of the fact that I made these unit rates, just use your number sense to realize that this is still $2 more than I want to pay for 4 shirts. Okay? So the answer here, does this change your answer? No. 42 is still too high. So my answer is it would need to be less than $40 for me to change my answer. Okay, we've been talking about units a lot, and now we're going to finally talk about unit conversions. I am willing to bet that you have done unit conversions somewhere along the way. So I'm going to re-show you how to do this. Hopefully it will jog your memory, because you have done this before. When you're using units, you might need to convert units before you can come up with the answer that makes sense. Like I'll give you dollars and cents, or I'll give you miles and yards, or I'll give you cups and pints. In order to work with those numbers, they have to have matching units before you can work with them. You might be given a distance in feet, but you'd rather know how far that is in miles. How far is it from here to Basin? 7 miles. How come you didn't tell me how far it is in inches? Yeah, because that's ridiculous. Who wants to know the distance in inches? Nobody, right? You tell it in miles, because that makes sense. To convert units, set up a series of rates. We know what rates are. Set up a series of rates being multiplied together. So for example, how many hours are there in 330 minutes? Well, the first thing we need to do is realize that we're looking for hours and we're given the thing in minutes. So, set up the problem. We're given 330 minutes. 330 minutes. And I'm going to put it over 1 because I need a rate. Then what I'm going to do is start forming fancy ones with another rate. This isn't that bad. If I want minutes to disappear, I have minutes sitting in a numerator here, which means I need to divide by minutes. So I need to put minutes in the denominator over here. Minutes divided by minutes forms a fancy one, and they disappear. But I don't want just a number, I want hours. So what I'm going to do here is put hours in the numerator. So I've turned minutes into hours that way. So I have to figure out how many minutes there are in 1 hour. How many minutes are there in 1 hour? So in 1 hour, there are 60 minutes. And now I just have fractions that I can multiply across. So if you take a look, just make sure that your units are actually disappearing here. The minutes divided by minutes is gone, and I'm left with hours, which is what I was looking for. So multiply across, and I get 330 times 1 is 330 hours divided by 1 times 60, which is 60. That's a fraction that I can get a decimal for. So what is 330 divided by 60? What is it? 5.5 exactly? Okay. 5.5 hours. That's your answer. So the key here is you set up the original thing. You need to get rid of your units. Slowly turn your units into whatever units you're looking for. And then you multiply your numbers across, and then you reduce that number down. It's a very simple process, but it's easy to make a lot of mistakes, so pay attention. How many meters are there in 1,250 centimeters? Well, I can take my 1,250 centimeters, because that's what's given to me, put it over 1, and now I want to turn centimeters into what? Meters. So, how do I get rid of centimeters? So where do I put centimeters in my next ratio? In the bottom. And what am I putting in the numerator? Meters. All right, so now I just need to figure out how many centimeters there are in a meter. That's how many inches there are in a yard. How many centimeters in 1 meter? The nice thing about the metric system is it's built on a base 10 system. If you look into your planners, you have a whole page, or maybe even 2 pages, of unit conversions. You guys will be using those in this section. So make sure you have your planners with you. They're also in the book. If you don't have your planner, in the back of the book somewhere, there's some conversions. Okay, so we have centimeters divided by centimeters, which divide out. They're gone. And I'm left with just the meters. So now I can multiply across. 1,250 times 1 is 1,250 meters over 1 times 100. So that's 100. And then I divide that out. What do I get? 12.5 meters. There's your answer. All right, let's make it a little bit more fun. The CN Tower in Toronto, Canada. That's the CN Tower right there. It's huge. It's about 1,815 feet tall. And you can actually go up to here. There's a restaurant right there, and the restaurant revolves around. And it's got like a glass, glass all the way around. Yeah, the restaurant spins up there. So as you're eating dinner, you're revolving around, and you get to see a nice view of the whole city of Toronto. It's pretty cool. Eventually you get over the fact that you're up, 1,000 feet into the air. The tower itself is 1,815 feet tall, but the restaurant you can see isn't nearly as tall as the entire top of the tower. So anyway, it's a lot of fun to go up there. If you ever have the chance, I'd do it. And it's not the only one around that you can do that on. The Space Needle in Seattle is very similar. It's not as tall though. Okay, so we have the CN Tower is 1,815 feet tall. How many meters tall is the tower? And then it tells you to use the fact that 1 meter is this little wavy line thing. That means approximate. If you look on your calculators, above the enter button, you see the little wavy lines? That means approximate. What you're doing is you're telling the calculator to approximate the fraction that it came up with. So that's why you press Control-Enter to get the decimal there, okay? That's what those wavy lines mean. So anyway, use the fact that 1 meter is approximately 3.28 feet. So, I'm given what? I'm given the height of the tower, which is 1,815 feet. Put it over 1 times, set up the next rate. I want to get rid of feet. So where does feet go? Goes in the bottom, which makes what go on the top? Meters. That's the nice thing about doing this. It's very easy to place those units in the right spots. So we have numbers that we have to put in there. What am I going to put in for M? 1 meter is 3.28 feet. All right, do feet cancel? Yeah, we have feet divided by feet. Those are gone. I'm left with just meters, so I put my equal sign, and I can go ahead and do that math. We have 1815 times 1, which is 1815 meters, divided by 1 times 3.28. So 3.28. And then we can go ahead and do that. 553.354. What? What? Meters. Don't forget your units in the end. It didn't say to round, so I didn't. If it said to round to the nearest tenth or something like that, then we would round to the nearest tenth. Okay, Cloud Peak. You guys know where Cloud Peak is, right? Oh yeah. Everybody knows that one. Cloud Peak is the highest peak in the Bighorn Mountain Range. There's its height. How tall is Cloud Peak in meters? Go ahead and do that one on your own. How do we set this one up? Okay, times. Got to get rid of feet. 1 meter over what? We're still using that conversion right there. So it's 3.28 feet. Just because it's a different problem doesn't mean the conversion doesn't work anymore. It still works. So we multiply across, the feet cancel, and I'm left with 13,166 meters over 3.28. What do I get? .014. 0.02 meters. Okay, so if you need to, you can use this conversion here always, because it's true. All right, next one. The current exchange rate, actually this isn't the current exchange rate anymore, but it was, like last year, for US to Canadian dollars. If you go over to Canada, you would have to turn your money in and they would give you Canadian money, okay? And there's an exchange rate for that. You don't get exactly the amount of money that you give them in Canadian money. If I give them $100, I would get back, according to this, a little bit less. Or a little bit more based on what I'm turning in, okay? So the current exchange rate for US to Canadian dollars is, I give them 97 cents US, they give me $1 Canadian. If you went to Canada and exchanged $25, how much would you get in Canadian dollars? What? How much would you get? We need to figure this out. So we need to set up the first rate. US to Canadian dollars. We have 97 cents US for every $1 Canadian. Okay? Now, actually, let me redo that. I'm sorry. Let me clear this off. We're starting with $25 US. I was doing something like we would do in the next sections. We start with $25 US over 1. We want to convert it using our exchange. I want to get rid of my US dollars, so that means I need to put US down in the bottom here. That's why I had to start over, because I reversed it. And then that means Canadian is going to be up top. Now we can put that rate in there, the conversion rate. US is going to be 0.97 for every $1 Canadian. So now if I give them $25 US, how much will I get back in Canadian money? Well, the US is canceled, and I'm left with $25 divided by 0.97. 25.773, and this is money, so it's $25.77 Canadian. So that was a year ago. This value has probably changed. It always changes. It's usually pretty close. It used to be that the United States dollar was a lot stronger than the Canadian dollar, and you could go with $1 US and get about $1.25 back Canadian. So you could do that with Mexico as well. You can take $1 in the United States and take it down to Mexico, and you get like 10,000 pesos or something, okay? Because their money is not as strong as our money is. As our economy changes, then the strength of the dollar changes, and those money rates change. Interesting thing is, some people make millions of dollars a year just moving money from one currency to the other. They'll watch for little changes in money, like the US dollar got a little stronger. So they'll take the US dollar and like millions of US dollars, and they'll put them into like the yen or something. You guys know what the yen is? Japanese? Yeah. So they'll turn all the US money into Japanese money, and then they'll wait for the dollar to drop down a little bit more. And then they'll move all that money back. So what they're doing is they're playing with the exchange. See how we gained 77 cents here? If we kept this money Canadian and then moved it back to US when the US dollar got a little weaker, we wouldn't have $25 anymore. We'd have like $25.03 US. If you do that over time with millions of dollars, you start making lots of money doing that. And there's people who do that. They spent their entire careers moving money from one currency to the next, making money. It's interesting to do. I have a $1 million bill from Turkey. It's worth about 12 cents. But if the U.S. economy ever really tanks and the dollar really gets weak, that $1 million bill from Turkey is going to wind up being worth maybe thousands of dollars. So I'm hanging on to it, hoping that maybe the economy tanks so that I can exchange it.